Hello students, today's topic is kurtosis. Okay. So in its statistics, kurtosis refers to the degree of flatness or peakness of the frequency distribution. That means if we draw a frequency curve, how peak the curve is and how flat the curve is. So kurtosis give us the idea of the central part of the curve. Okay. And that means how peak the curve is or how flat the curve is. Two or more distribution may be identical in terms of central tendency, that means they have same central tendency. Okay, dispersion or skewness. Okay, two or more distribution may be identical in terms of central tendency, dispersion or skewness. Okay, but they may be more concentration of values near the mode of one distribution than the other. Okay, that means let us suppose we draw a frequency curve. This is your frequency curve. This curve is neither peak nor flat. Okay, so this, as you know how to draw frequency distribution curve, you use histogram also. Draw a histogram first, then join the midpoint, you will get this. Okay, or directly you put the coordinates by taking x along x axis and frequency along y axis. Take the coordinates and join the coordinates, you will get the frequency curve. So this curve is neither peak nor flat, it is a symmetrical curve. So in statistics, symmetrical curve are called mesokartic. Okay, I will write it afterward. Let draw another frequency distribution curve. This. Now look here. Here, as we know, we get mean median mode here. Since it is a symmetrical distribution, this is also symmetrical distribution, means skewness is absent, and dispersion is also same. Okay, that means the dispersion from the mean value, this is your mean value, the dispersion from the mean value is same. So we get same central tendency, same dispersion and same skewness. Let's take another frequency distribution. Suppose this is your another frequency distribution. So in all the three frequency distribution curve, central tendency is same. That means it is all are symmetrical distribution. So we will get mean, median, mode, all the values here. Okay, we get mode, mean and median here. So these three are different frequency distribution, but we get the identical central tendency. Okay, now next is dispersion. So dispersion is also same. If we find the standard deviation, we get same standard deviation for all these three frequency distribution. Okay, next is skewness. Skewness is absent. Skewness, when we calculate skewness, we will get 0 skewness because all the three frequency curves are not skewed. Okay, but still they are differ in their shape. Only the middle part of the curve is differ. So look here, that means the concentration of the values near the mode is more here. Here it is normal and here it is less. How? Because the frequency is more. Against whatever be the value of x, the frequency is more here. That means more values are closer to the mode value. Here, as compared to this, less values are closer to the mode value. Now look at here, very less values are closer to the mode value because frequency is here, frequency is less. That means the value closer to this mode value, whatever be the value of mode, suppose the mode value is 25. So many values are here. Okay, so the frequency is, suppose here it is 100, it is 75 or it is 25. So that means the more values are closer here. In this case, more values are closer to the mode value. Here less as compared to this, and here less as compared to this two. So we get flat curve here. So it give us the so Kurtosis give us the idea of the values closer to the mode value. Okay, how concentration of the values toward the mode value. So this is the way of finding Kurtosis. If you draw the curve, then also you can find through curve the Kurtosis is which have more Kurtosis and which has less Kurtosis. Okay, or you can find this Kurtosis by mathematical method which is based on percentile, which is given by Cayley's. So it is Kurtosis is equal to P75 minus P25 divided by P90 minus P10. So this is the formula which is given by Cayley's. Okay, so if you apply this formula, you will get the value of Kurtosis. Okay, if the value of Kurtosis is greater than 0.261 0.26315, okay, if Kurtosis value is greater than this, it is a platykurtic curve. That means platy one, this is your platy, last one is platykurtic. This curve is called platykurtic, and the first one is called leptokurtic, and this is called mesokurtic, which is normal curve, mesokurtic. Okay, so if your value K value, that means Kurtosis value is greater than 0.26315, then the distribution is platykurtic. That means it is a flat curve. Okay, if your K value is less than 0.26315, then it means your curve is leptokurtic. Okay, leptokurtic. So you can use K also now, leptokurtic. So this is the way of finding Kurtosis. Either you plot the graph and check the middle part of the portion, that means the middle part of the curve, how peak the curve is from the middle part and how flat the curve is from the middle part. So Kurtosis means peakness of the distribution, or measuring Kurtosis means to examine the extent of peakness of a distribution as compared to the normal distribution or symmetrical distribution. That means normal distribution is neither flat nor peak, it is called mesokurtic. So hope you get the idea. This is the way of finding the Kurtosis mathematically by using percentile formula. So if you use this percentile formula, you will get the value of Kurtosis and compare as given. If it is if K value is greater than 0.26315, then it is a platykurtic curve, that means flat, or if K value is less than 0.26315, then it is a leptokurtic curve. Okay, and if you get closer to this value, that means 0.26315, that it is means mesokurtic. So hope you get idea of Kurtosis, what is Kurtosis. Okay, thank you.